Okay, today we're going to take a look at Investigation 3.4 out of our Primetime book, and we're going to focus on the characteristics of numbers such as factors and multiples and how those are used to answer questions, and then special numbers such as prime and composite numbers or even square numbers and how those are used in solving a problem. So we're going to scroll down and look at the locker problem that's in our book. All right, so there are 1,000 lockers along a hall in a high school, and the lockers are numbered from 1 to 1,000. So they're just like this picture here, only they're labeled clear up to 1,000. All right, and when the students return, they decide that they're going to celebrate the beginning of the year by working off some energy. So student 1 goes along the row and opens up every locker door. Okay, then student 2 closes the doors of lockers 2, 4, 6, and 8, and so on until the end of the line. So what student 2 is doing is shutting every even door, which is going to be a multiple of 2 and would have 2 as a factor. Student 3 changes the state of the doors for lockers 3, 6, 9, 12, and so on, counting by threes. So changes the state means that if the door is closed, they open it, and if it's closed, if it's open, they close it. And so what student 3 is doing is changing the state of the multiples for 3, or any number that would have 3 as a factor. Student 4 is going to do the same for lockers 4, 8, 12, 16, 20, 24, so on and so forth. Student 5 is going to do the same thing for every 5th door. Student 6 for every 6th door. Student 7 for every 7th, so on and so forth, until all 1,000 students have done it. All right, so the question is, when all 1,000 students have finished, which locker doors are open? Well, let's take a look. Let's take a look at a model of some lockers. All right, so right here, right here I have some lockers. This is my locker room in my hallway, and I'm going to put an O for open and an X if we close it. Okay? So the first guy runs down and he opens all of the doors. So they're all going to be open. So that's what we're doing. He's going to open all 15 lockers. We're going to pretend that we only have 15 students in our high school. Okay? So all of the doors are open. And then student 2 comes along and closes all of the doors that are multiples of 2 up to 15. Okay, so now these doors are closed. 2, 4, 6, 8, 10, 12, and 14. Again, they are multiples of 2, and they are also factors, or would have 2 as one of their factors. All right, so now student 3 comes along, and he changes the state, or she changes the state of every 3rd door. So now student 3 comes along and changes the 3rd door. So 3, 6, okay, better write these down. So this would now be open. This one would be closed. 9 is going to be closed. 12 is going to be open. And then 15 is going to be closed. So I'm going to real quick erase the other mark I made. All right. And then student 4 comes along. Okay, and since the door is closed, he's going to open it. Then he goes over 4 more doors, opens up that door, goes over 4 more doors, closes the 12th door, and then he would actually go into locker 16, but we're not there. All right, so now we're on student 5. Student 5 is going to come along, and they're going to change the state of every 5th door. So student 5 comes by. Since door 5 is open, they close it. Okay, since door 10 is closed, they open it. Since door 15 is closed, they open it. All right, so we need to erase our earlier marks. Okay, and then student 6, so on and so forth. They're going to change so that when all 15 people have gone, this is what happens. Okay, and I included a 16 over here. So we would have door number 1 would be open, door 4 would be open, door 9 would be open, and door 16 would be open. So let's take a look at what kind of pattern that is. Okay, you're supposed to come back to class tomorrow with having problem A1 and A2 done in your spiral notebook. So let's take a look. Let's take a look at these. 1 is open. Whoops, need to turn that on. 1, 4, 9, and 16 would be open. And then I'm also going to put another number that would be open, which would be 25. So let's take a look at these. These are a special type of number. Okay, 1 is not prime or composite, so we're going to exclude the 1 for a second. All of these numbers, 4, 9, 16, and 25, and all of the other numbers that are going to be open are going to be composite numbers. But they're also what kind of number? Multiple of 4 would work for 4 and 16, but not for the 9 and the 25. A multiple of 9 would not work. Okay, so think about it. What numbers are these numbers? And that will help you figure out which doors would be open for all 1,000 lockers. All right, so this is just a small example of what happens. Okay, so we need to look at the patterns that we see. Well, one pattern I see is that these are all, other than being composite numbers, with the exception of the 1, they are all square numbers, okay? Because we can find 1 by multiplying 1 times 1. Okay, we can find 4 by multiplying 2 times 2. We can find 9 by multiplying 3 times 3. Okay, we can find the 16 by 4 times 4. See, all of these are square numbers. And the reason why we call them square numbers is because if we made a model of these numbers, you'd get a square. If we had 4 rows of 4 items, and these pictures are not very good because, you know, I'm not a very good artist, it would be a square. So if you have a piece of graph paper there, count over 4 squares and then up 4 squares, and you get a perfect square. All right, so they're square. This would be a 4 by 4 square. We'd have 16 squares on the inside. We're going to be looking and continuing this conversation in class today, or tomorrow, and we need to kind of figure out what other patterns there are. Now, another part of this problem is looking at the doors that were opened and why. So let's take a look at which doors are open. Open doors would be 16. Now, how many kids touched this? Which student touched door 16? Okay, so if I'm looking for which students touched door 16, I'm looking at the number of students, or which student in that line, student 1, 2, 3, 4, so on and so forth, would have touched door 16. So here's the number of the students. So students 1, he would have touched all of them. So we know he touched 16. And then student 2 went by and closed all of the even doors. So student 2 would have touched 16 as well. What about student 3? So let's see. If he touched the third door, that'd be 3, then 6, then 9, then 12, then 15, but he would have went past 16. What about student 4? Student 4 would have touched doors 4, 8, 12, 16. So student 4 would have touched that door. Okay, what about student 5? Well, it doesn't end in a 5 or a 0, so that's not going to be one that was touched. Okay, and what we're going to find is that student 8 and 16 will also touch that door. But what are these? What are these in relation to 16? These are the factors of 16. Okay? So this number of students who touched any given door is going to be how many factors that has. So 16 has 5 factors. There would have been 5 kids that touched the door. Okay? the students that touch the door are going to be the factors for that number. All right, I know this video is long, and I know it's kind of confusing, but don't worry about it. We're going to take a couple of days to kind of get through this whole locker thing and kind of look at the special relationships that numbers have and the patterns that are related to those. If you have any questions, feel free to email.